Hi all, it's Kate from KatyDid. Let's talk about rocks. Today we're going to talk about the Fort Union Formation. This is a rock formation where I live here in eastern Montana, and I didn't know too much about it, so I did some research and now I'm going to share it with you. The Fort Union Formation is a vast geologic formation, is just about as big as Texas. It covers 5 states and 2 provinces. So let's step back in time. 66 million years ago, an asteroid impacted the Earth, volcanoes were erupting, it created a really bad situation for the dinosaurs that were living at the time, and they became extinct, except for the avian dinosaurs who survived and became birds. But anyway, most of the dinosaurs, kaput. So, fast forward 6 million years to 60 million years ago. Imagine a place that's jungly and it has vines and high heat and humidity and it is just tropical. And this was Montana at the time. So outside my window right now I have snow and snowy hills and it's cold, and it's really hard to imagine that Montana could have been tropical at one time, and it's just hard to imagine. But you know, geologic time is really something very different. It's a long time ago. 60 million years is a long time. All right, so this area, this tropical area, is about the size of Texas. It's bordered by the inland sea, and it has torrential rains. You know, if you've ever been in the tropics, when it rains, it is just like crazy downpour. And so it's torrential rains that would then wash sediment down from the mountains, and it would just come whooshing down in these large amounts of water, and it would carry along silt and sand and clay, and it was just really rich with all of these different types of sedimentation. And then it would whoosh, go off, and it would hit the eastern part of the state where it's basically a flatter, it's a basin. And because the water slowed down, all those particles fell down out of the water. And then so the silt and the clay and the sand, they all compacted in different areas. They fell out in different places, and then they became compacted through pressure. So the floodwaters rose and the plants compacted over and over again. The plants and the sedimentation got kind of layered on top of each other. And eventually the compacted plant material became peat, and then after that it became coal. In this area there are billions of tons of coal. I mean, a lot of coal. All right, so the compacted sand, silt, and clay became sandstone, siltstone, and mudstone. So those things are sedimentary rocks. They're really similar, but they are different because they have different composition. And the rivers washed the looser stuff away, and that's what made the sandstone cliffs. So let's talk a little bit about sandstone. I love sandstone. If you've watched my videos of walking around eastern Montana, you know I am always geeking out about sandstone. Sandstone is what we call a clastic sedimentary rock. Clastic just means that it's made up of a bunch of little pieces, so fragments, and that's, in this particular case, the fragments are sand. And those little pieces are actually called clasts. So now you know some geology jargon. Most of the sandstone is made up of quartz or feldspar, and both of those are silica-based materials. And those things are deposited on a river, the bottom of a river or a seabed, and they're compacted by pressure, and then they're cemented together with other minerals. So this is how, it's not just the pressure, it's also the precipitation of water that holds other minerals that binds it together. So most of the sandstone is held together with either calcium carbonate, silica, or iron oxide. And so that's how the sandstone then is formed. Now let's take a look at another really important part of the Fort Union Formation, which is coal. Coal is kind of controversial these days, and I know that it's, and I have no wish to get into that particular discussion with anybody, but the fact remains that there is a large amount of coal in the Powder River Basin, Powder River Basin. I seem to have trouble saying Powder River Basin. Powder River Basin is an enormous shallow bowl in the earth. Basically, it was compressed down flat with the weight of what was above it, and it contains 200 billion tons of coal. There are 32 major coal seams in the Powder River Basin, and they are totaling 300 feet tall of coal. And these coal seams then periodically would catch fire. Ways the coal could be set on fire: lightning, spontaneous combustion, chemical reaction, and this is something I found really interesting. If a tree that has roots in the coal is burning, it can burn all the way down and literally start the coal seam on fire through the roots. I thought that was amazing. The coal has been burning in what is now eastern Montana for 4 million years. Even today, there are underground coal seams that are burning. The coal seam would start burning, and it would burn into the hillside, and it would heat all of the sandstone layers above it, and those sandstone layers then would become, in pottery terms, we would say that this coal fired the clay and silt and sandstone that was above them. And you can really look at the hills and realize that these have been literally baked by heat. Lewis and Clark saw these red hilltops as they traveled the Missouri and Yellowstone rivers, and they called them burnt hills. And I guess that's a pretty accurate name. The stuff on the top, the red stuff, looks volcanic, so a lot of people around eastern Montana call it scoria. Scoria is actually a volcanic material, and since this is not, it's not actually named properly. Geologists call it clinker. And scoria is kind of a nicer name, but clinker sounds kind of like, it's not that nice. The sand, when it is fired, becomes kind of a brick-like sandstone. The shale that is formed from the silt makes something called porcelainite. Porcelainite is literally fired clay, and it's hard and it's sharp. The edges are sharp, and Native Americans used it for scrapers and knives and arrow points. And then finally, there is some stuff that was superheated, and so it literally melted and bubbled and created what looks like lava, even though it's really not. And those are the 3 types of sandstone that you find in the hills. The clinker beds in some places are up to 100 feet tall, so they're very, very large. And they also have the benefit of filtering the water as it precipitates down, so that the hills don't erode as quickly. And so that's why you have lots of red top buttes in eastern Montana, is because those caps of the clinker actually protect them like a little umbrella on the hill. And that's what makes those distinctive red top buttes. So today, as you're out driving around in the hills and buttes of eastern Montana, or if you are looking at a video and wondering where these things came from, hopefully now you know a little bit more about the Fort Union Formation, you've learned a little bit more about sandstone, and you understand a little more about how amazing our natural world is. This is Kate from KatyDid. Keep on doing.